Blood Clot channel. In today's video, I will be replacing my AGM battery bank to a lithium battery bank for my AEPU system, which is the battery operated AC system, as well as my inverter for the microwave, TV and other accessories. It will be done on a 2019 Kenworth T680 MX13 EP17. Stay tuned. So, in case you're wondering why I'm replacing my AGM batteries with lithium battery, in a nutshell, when they were working properly, the AC system, when the truck is off, would run for like 5 to 6 hours. Of lately, it kept running for like 1 hour or 2 hours maximum. So I called the manufacturer to see what is up, and I took off the fairing and checked the secondary battery, and they were swollen. So they are saying that because the battery discharged so deep, and then when the truck charges them back up, there's a thing called sulfation which causes the battery to be swollen. So they recommend that I don't use those battery anymore because it is dangerous. So that is one of the reasons why I'm switching over to lithium. Second point is those AGM comparing to the lithium battery, it's a new technology, whereas the AGM batteries didn't have any type of way to monitor the depth of discharge and monitor the battery itself, or BMS. There's one on this truck, but it is not perfect, and it causes the battery to discharge to maybe 10%, 13%. By the manufacturer's specification, 10% would have shortened the life of the battery. They're saying that it should be discharged below 50%, and the BMS on this truck discharges them to like 20% before the truck starts and charge up the battery. With these lithiums, based on research and all of that, they can go down to a 0% discharge, and also you have to install a battery charger to charge these lithium, because they are different from like lead acid, gel, flooded and also AGM. The charging system is different, so you have to get a DC to DC charger. That charger have a built-in protection for overcharging, temperature, low discharge and all of that. And also the batteries themselves, that's the lithium battery, they have built-in BMS to protect the battery from what I just stated earlier. So over discharge and low temperature, high temperature, shorts and all of that. So based on technology, it is better in my opinion. So this is the reason why I'm here to test out the setup, and I will inform you guys if it works out for me. So those are two of the main reasons. So in today's install, these are some of the items, parts, tools I'll be using. First up is these 4 lithium battery, and in this box is a DC to DC charger. Here we have a riv nut tool, and I have a bunch of bolts, washers, lock nuts, wire cutters. I have a bunch of 0 gauge and 4 gauge wire. Have anal fuse block. I have lugs if I have to make wires or connection like these. And these are some anal fuses. I have some regular fuse. I have wire ferrules, heat source, wire cutter, heat shrink, solder gun, ratchet, more wires, and I'll be using a 17, a 13, and also a 10 mil. It's just to take off the step, which using 17. There's a 13 mil right there, and there are a couple 10 mil right there, and some 13. So I also have heat shrink and a bunch of more stuff. So those are just some of the tools. So this was what I was talking about. You can see they're all swollen. Yeah, no good. So yeah, that's the reason why I'm replacing it. So shit, let's knock this out. So the next step is to just get these batteries out. It's sort of hard to disconnect these because they're live and they're connected to the other side of the battery. But what I'm going to do is just one lead that is going to be live, and it's this one. So as soon as I get this off, I'm going to put tape on it so I don't circuit anything. So yeah, let's get that. guys, it's worse than I thought. Yeah, it's worse. Yeah, this is what it looks like. It's really bad. So, yep, that's it. Guys, I was recording because to me, I think some of this is boring and is just repetition. So, as you can see, I have all four lithium batteries mounted. They are all group 31, so they'll all fit. So, what I did was, as you can see, it has battery tie downs. They are loose, except this one because it's separate. So, all I did was push these, I don't know what to call these, but I push them from underneath where they're supposed to go. Then I just put a washer and a nut. These will have all of them. So it's 1, 2, 3, 4, 5. So that's all I did. Just put the batteries in place and put these all down or tie down in the respective spot one by one, all five of them. So that's it. Next thing that I did was these bus bars. This is the negative. So I orientate them how I took them out basically. And what I did, as you can see right here, I can show an example. I just use a drill wire brush, clean off the ends. And as I said guys, it's just repetition. It's not that hard. So because you want a clean connection. So just imagine me doing that a bunch of times. And same thing I did, because this negative connect to those four negative. So I just clean off the ends. Yeah, so as I said, it's just repetition, and to me, I think it's boring. Maybe to you, it's not. It's not like a full in-depth auto video. And then what I do is just those washer and locking nut and all of that, I just switch them over. The batteries came with these. They're, as you can see, they're a bit shorter, as you can see. And the ones that I bought are they're stainless steel. So I rather run stainless steel to eliminate as much rust as possible. So yeah guys, it's like basic stuff, removing and installing these batteries and terminal. When I get to the technical part, I'm gonna start recording, because that part is gonna be interesting, where I'm gonna mount the DC charger. So yeah. So I guess I have to figure out this one. It's kind of different. I'll figure it out. You can tell work is being done when everything is all over the place. Yeah, so these are the riv nuts. Let me update you guys where I'm at. So this is what I figured out with this. I just use a zero gauge to connect this positive to this positive. I already had this negative, it's a zero gauge, so I connected to this battery to the bus bar. So from this battery to the bus bar, so 1 2 3 4, 1 2 3 4, it's all connected. This right here, as you can see, two fuse bar. That's what I decided to do. So what I did, I just drill through each side. Use this punch first. If you don't know what a punch is, it sets a point right there, and you just drill. So if you can look behind it, and these two are coming from the starter battery, and these connected run up into the cab to a fuse bar. So this, just to show that it's working, this is the inverter. It is connected inside at the fuse bar, as well as my amplifier and also the AC system. So if I turn this on, technically I should have power. Boom, I have power. As you can see, it's like 13.5. So yeah, that's where I'm at. It's getting dark, so I have to try and finish this tomorrow because I have to drive out. I have a delivery in Florida, and yeah, that's why it's been rough to record, but based on what I did so far, yeah. So tomorrow, this is what I have to figure out, where to mount this DC to DC charger. But what I am thinking is this goes over the battery box, and I'm thinking I'm going to mount it right here, and I have enough 4 gauge wire, or if I so please, I can use 0 gauge and mount it to this. But I'm gonna give it some length, so whenever I take this battery box off, I can service it. So that is what I'm going to do tomorrow. So battery box will go up here. I'll give it some length, so whenever I pull it off to maybe around here, I'll have space to service it. And I went ahead with the fuse block, so it is equal length. So I'm gonna run a positive and a negative from these right here. Obviously I'm gonna fuse it, run it to the DC to DC charger, then from the DC to DC charger, run a positive to here and a positive and a negative to here. So yeah guys, that's where I'm at with this install. I started very late today, and yeah, that's where I'm at. So I'll pick this video